Let's see what's happening here. A chemist fills a coffee cup calorimeter with 50 grams of water. He then adds a sample of potassium hydroxide and stir the mixture until all the potassium hydroxide dissolved. Well, so we have the sample of potassium hydroxide put into the calorimeter that filled with water, 50 grams of water. So potassium hydroxide, if you're not sure, if you don't know, so adding water, it releases heat. So the temperature of water goes up, all right? So here we go. The temperature rises from 24 to 46.4 degrees. I know that I'm going to need to use the delta T. So I'm going ahead and calculate it. So 46.4 minus 24 degrees Celsius. So you get 22.4 degrees Celsius different. Okay. Based on this result, how much heat energy does potassium hydroxide release? So how much? 5.21 gram of potassium hydroxide release total. And I calculate the heat of solution of potassium hydroxide in kcal per mole. Okay, not bad. All right. Start with the total energy release first. Okay, so Q of reaction. All right, so in kcal per mole. All right, so one loses, one gains. So potassium hydroxide release energy, and the solution gains energy. Okay, so mass, specific heat capacity, and delta T. These are all from the solution. Mass of the solution is 50 grams of water plus 5.21 grams of potassium hydroxide. Okay, the specific heat, we still use the specific heat of water because the property of water doesn't change that much. And delta T, so the temperature goes up 22.4 degrees, so it goes up. All right, so gains heat and the temperature goes up. Do the math there, you should get that this number. All right, times -1 on both sides. Sorry. Change the decimal first, 1, 2, 3. You get 5.174, blah, 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 times 10 to the third. And then round them down, 3 sig fig, 22.4. Okay? So you get 5.17 kilojoule times -1 on both sides. You should get, so the reactant loses energy by 5.17 kilojoules. All right? So that's the first question. Now the second one, the enthalpy of this solution. All right? All right, now we're going to find the enthalpy in kcal per mole of potassium hydroxide. This number is the energy released per 5.21 grams of potassium hydroxide. We want to find it per mole in kcal. Okay, so I'm going to use so put right here. So this energy released per 5.21 grams of potassium hydroxide. Okay, so you have to do convert grams to mole and joule to kcal, basically. All right, grams to mole first. So grams at the bottom, I put grams at the top per mole. This is the molecular weight of the potassium hydroxide. Okay, all right, gram cancel out. You got moles. Next one, joule to calories. So put joules at the bottom, calories at the top. Joule cancel out. You can add the cal to kcal right here, but I'll show you. So you can go further from here. So do the math. You should get that number. Cal per mole potassium hydroxide. I'm going to convert, move the decimal 1, 2, and 3. Negative 13.33, blah, 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 times 10 to the third. 10 to the third, that's kcal. Okay, you can do it this way too. All right. And so how many sig figs are there? 3 sig figs. So 1, 2, 3. So this guy right here. Round down, should get that 13.3 kcal. Oh, I missed the negative right there. So negative. Don't forget that. Okay. All right. So class activity number 4. So practice makes perfect, guys. So try that. Okay.